Hello, my name is Connor Smentek,
My name is Iman Yunus.
and we will be talking about cryptography today.
What is cryptography? Cryptography is the science of hiding or coding information so that only the sender and receiver can view the decrypt in contents. The word cryptography comes from Greek word cryptos, which mean hiding. Cryptography is used for secure communication, digital signatures, electronic money transactions, and cryptocurrency and more. Cryptography also is subject of transforming information so that cannot be easily recovered without special knowledge. Also, number theories plays a key role in early cryptography, as it is the base of many of the first cipher. Cipher works by changing each letter individually or block letters into different letters through math. So the goal of cryptography is to allow the intended message to receive the message securely. History of cryptography. The first known evidence of cryptography encrypting a message date back to 1900 BC in Egypt and nobleman tomb, even though the writing in tomb was not encrypted. It's introduced the concept of rearrangement or substitute section of writing for something else. One early cipher that you might know, it's called scissor or shift cipher. That's a bird in 100 BC. The first cipher that using an encryption keys was designed by Visionaire in the 16th century. Many more form cipher comes into begin after everything become digital, like the Hebron rotor machine, the Enigma machine, Lucifer, and many more.
How does it work? I'm just going to show a mini example of how cryptography works. The Caesar cipher works by taking each individual letter in a sentence and changing them into a letter that is plus k or minus k from where the letter is in the alphabet. For instance, H, which is the 8th letter of the alphabet, if we were to add 4 onto that, it would become the letter L, which is the 12th letter of the alphabet. And if we continue to do that with all the other letters, we get the ciphertext that you see in the middle. Since the Caesar cipher is a private key cryptosystem, finding the shift key could be easily done through brute force to decrypt it back into the original message.
Our example today is the RSA. So the history of RSA system was created by Rivest, Shamir, and Adolman in 1976, but was actually discovered in 1973 by Clover, who works for the United Kingdom of Kingdom Government Communications Headquarters in secrecy, and couldn't reveal his discovery until later. It took Rivest and Shamir 43 different times to create a coding system that Alderman couldn't break it to create the RSA system. Actually, the RSA system was going to be called ARSRS system after the first letters of the last name of the inventors in alphabetical order. But Adelman felt like he doesn't contribute enough to be stated first. So for that reason, it's RSA, not ARS.
The example we're going to be showing you today is RSA encryption and decryption. The RSA system usually uses two large prime numbers that are around 300 digits long each, but for this example, we'll be only using 2 digits. With the RSA system, each person has an encryption key, NE, where N equals P times Q, which is the modulus. The variables P and Q are prime numbers, and the exponent E is relatively prime to P minus 1 times Q minus 1, which is the modulus W. The equation that we use to encrypt the message M into ciphertext C is C equals M to the power of E modulo M. The variables that we will be using today is P equals 43, Q equals 97, E equals 17, N is 4171, and the message that we'll be using is cryptography rules. So first, what we do is we convert the letters into numbers, and whatever the number that we usually get, we minus that by 1 and add on a 0 into the front if the number is between 0 and 9. So A would be 0, 0, B would be 0, 1, and C would be 0, 2, all the way up to 0, 9. The next thing that we do is that we check to see where the modulus N is in between. So we see if it's between 2,525, which is 2 z's put together, or between 3 z's put together, which is 252,525. If it is between those, then we group 2 letters together, or 4 digits together. And if we cannot fill out all the blocks together with 4 digits each, we add on extra x's, or 23 at the end. And then after we do that, after we split them all into different blocks, we take those blocks and make them equal to a smaller message, or M1, M2, M3, and so on. Then what we do is we take all the little chunks, the little messages, and put them into the equation to get back C1 from M1, which is M1 is 0 to 17, and then we get 1814 after putting it into the equation. And as you can see, we continue on until we get the final message or ciphertext, as you can see along the bottom. Now we'll move on to RSA decryption. To get decryption to decrypt the ciphertext, we must find the multiplicative inverse of E modulo P minus 1 times Q minus 1, which is modulo W. And then we'll find the variable D by using the Euclidean algorithm and Béziers theorem. As you can see, after doing the Euclidean algorithm and Béziers theorem, we get the decryption key D, which is 2609. After finding D, we get the equation M equals C to the power of D modulo N. And we put all the little messages of C, like C1, C2, and so on, into the equation to get back the original message blocks that we usually had before. And then, after we put it into the equation, we get the original numbers for message M. And then, after that, we can convert those numbers back into letters, and then remove all the spaces in between to get the original message, while removing any remaining x's on the end.
Significance. Cryptography is significant within the field of mathematics and computer science since it's both related to math and the function of computer system. Its main significance is in the field of computer science because it's mainly used on computer system using mathematical equations to encrypt and decrypt information automatically. It has contributed to the development of computer science by maintaining the security of website, database, and other private information online. This allows more people and businesses to use the internet or digital technology more frequently and rely on them.
Why should you care about cryptography? There are many reasons why anyone should care, but the main reason is that it allows private information, like passwords, personal information, and secrets to be safe from falling into the wrong hands, like terrorists, scammers, or cybercriminals that can be found all around the world and can access any information if it's not secure.
What problem does it solve? The main problem that cryptography solves is secrecy. Secrecy between two or more objects, including people and businesses. The RSA algorithm is so secure because cryptography was made to solve secrecy. The ability for computers to factor large numbers and therefore attack schemes such as RSA is rapidly improving, and system today can find the prime factors of numbers with more than 200 digits. Nevertheless, if a large number is created from two prime factors that are roughly the same size, there is no known factorization algorithm that will solve the problem in reasonable amount of time. With quantum computing on the rise, the security of RSA crypto system could be threatened due the factorization algorithm that have been developed in quantum computers.
How is it applied to the real world? One example is that of a business. A card, whether it be credit or debit, is considered the private key, and the credit card authorization key, which is an encrypted code not visible to the customer or merchant, is transmitted between a merchant's point of sale and the merchant's payment processing provider, is considered the public key. And that is all that we have for you today. So thanks for watching.
Thank you.